Hello, everybody. This is Joel Harris. We have another minute here or actually a little bit under that before we start. Just wanted to let you all know that we appreciate you being here today and welcome. Um, we'll be starting in just a few seconds here as we reach a good number of folks are still joining, so I just want to make sure nobody misses out. This session will be recorded and available on the Autodesk Learning Hub, and we'll have that information towards the end. And all of our Plant 3D user community virtual meetups are recorded along with the PowerPoint decks. Any questions that were asked during the session are recorded and answered and then also posted up in our collateral that we have online. So we'll go ahead and start now. Just to let you know a little bit about, well, today I should mention before I jump ahead, my colleague Nabil Nuga is monitoring the questions, the Q&A session board with me. And so if you have a question, feel free to ask it there, and I will assign it to Nabil and continue to present while we're talking here, while we're going through this information. Some information about the GoToWebinar platform. You can ask a question using the questions tab, which is on the right there. You can enter your message there, and you can specify who you're sending that to. And then also you have the ability to join via your computer audio or phone. So please be aware of that. If you can hear my voice, you've already probably accomplished that. Okay, we've muted everybody's lines, so that'll help with background noise. It'll make for a nice clean recording, and if you have a question, you can raise your hand and I'll unmute you, or you can use the questions box as I just showed, and that would probably be the best route because then we can make sure that your question is answered by either Nabil or myself. And it also captures it in our log so that it'll be available for downloads later. And this session is recorded. And so as I mentioned earlier, the Customer Success Hub, which is customersuccess.autodesk.com/webinars, where you'll find these recordings as well as other recordings. So great. All righty, let's go ahead and move to the next slide. This is just a little bit about myself. I've been in the oil and gas piping design business for a while before joining Autodesk. I've got a background with the various products that you see there, as well as some other ones, which I'm still too modest to broadcast expertise in, but definitely willing to talk about piping here with you folks. And so I also have, like I said, my colleague Nabil with me. He is based in Dubai, and he's going to be helping me monitor the questions. So thank you, Nabil, for being here. I'm going to go ahead and signing some questions. And we have some questions coming in already. So if you can see those, Nabil, let me know. That'd be great.
Yeah, okay. I can see it.
Oh, good. Thank you. All righty. So we have a safe harbor statement here. And these statements here are just really that we do in this session are meant to be informative. They're meant to give you some idea of the current plans and plans for the software development in the future. But we certainly want you to make sure that any statements that we make in this webinar are not used for purchasing or investment decisions, because things do change, and the information that's in this session may not be accurate at any point in the future. So we do our best to avoid hyperbole and imagining too much of what things are going to look like in the future. But sometimes with the questions that come in, we do give indications of what future plans may be. So just wanted to put that up there for everybody. So in this month's agenda for this session is going to be around the ortho functions in Plant 3D 2021. And we'll talk about some of the new functions that were added, as well as some of the do's and don'ts for ortho drawings, and how to handle XREFs during ortho generation, as well as advanced steel and inventor model information some recommendations there. And so we'll go through these, and as well as a few follow-up questions from last month. So, okay. So for an overview, just want to let everybody know that our objective today is to help you understand a little bit more about the ortho template creation and how it works, and what are the do's and don'ts while creating them. Understanding how AutoCAD Plant 3D XREFs work within the modeling environment, and how those models are treated when you're generating your ortho drawings. So, and then finally, the scope of this session is the same as other sessions. It's intended to be a casual engagement, and we do a small portion of news if there was any. This month I didn't have any news to share, and then information about the product, as well as a general discussion of products and workflows. So at some point I will share some of the questions that are being asked. If there's something that we can share there with everybody, we'll do that. And we'll continue on here. Okay. So first we have the Plant 3D Ortho new features for 2021. The 2021 release did come out this year. In case you missed it, there was some new features added. One which was a real big announcement for us is the collaboration for Plant 3D on the BIM 360 Docs platform. And sometimes the larger announcements like that overshadow some of the other new features. And one of them that you may not have known about was the ortho features that we have. So one of the things that we've added is insolation features, which is affecting the orthographics because there's some ortho settings for how insolation is shown. So first off, in the 3D model, we have insolation shown in a transparent form, and I'm going to show you a little video that shows you how that works here. And also, insolation can be displayed with the pipe objects in the orthographic drawing, so you have control over whether you set up the ortho view, and that's what I'm showing there on the ribbon there in the upper right, is there's a no insolation or solid line insolation or hidden line insolation settings that you have there in the ortho view setup. You also, if you have an existing ortho drawing and you don't want to set the view to have those settings, you can also use an insolation tool to place an insolation symbol that's shown in the lower right there. So these are some of the new features, and the next slide will cover a little video, which I'm going to, hopefully, it will share the audio too. We'll see if this works. I'm going to ask Nabil if you could tell me when I start this if you can hear the audio.
Very faint, Joel.
Okay. I'm not too sure how to add that audio, if I can include that audio in the computer audio here. Just 1 second, folks. Appreciate your patience. Well, I apologize. I'm not going to be able to do that, so I'm going to have to basically narrate while Bern talks. So we'll see if we can do this with this video. See if that works. So first, what he's going to show here is the insulation is shown transparent in the model, which you can see at the very top up there. We have the insulation shown as a transparent cylinder or transparent shape around the pipe itself. And beneath that, we have uh, some other options that will be in the ortho. So first we'll look at the 3D model. You can see this is a plant 3D model where we've assigned an insulation thickness. This is a very small insulation thickness around this elbow and this pipe here. You can see that sort of halo effect. It's a transparency. It's on a separate layer in the 3D model, and it has a transparency. I think the default is set to 70%, and so you should be showing that here within a few seconds. This is toggled on using the ribbon. You can see up here there's the insulation toggle, and it is available to be displayed now in this mode. It no longer is in the old mode where it was completely solid and you couldn't see the pipe underneath it. Now since it is on a separate layer, you could always override the transparency on that, which you can see the layer here for pipe is 30 and it adds a underscore insulation automatically to the insulation layer. And you can see the default transparency 70, but you could override that to be 0 if you wanted to go back to the old display mode and see it without the transparency. But now insulation will appear on a separate layer, which is nice when you're bringing this into Navisworks or reviewing it inside of Plant 3D. And like I said, you need to turn that on here on the ribbon. When you bring in an XREF of another model into your model, you will actually see that XREF's insulation as well. So it does display properly with the layer transparencies through the XREFs. So you'll get complete fidelity on your layer views with these transparent insulation layers across the different models. So, okay, I'm sure Bernd is telling us some more stuff here, but we're going to have to skip ahead to your ortho views. When you have an ortho set up and you go into an ortho view, you'll see on the ribbon up there the insulation under output appearance on that tab or on that panel within the ortho editor tab. So we have our no insulation option there. We have solid line insulation, which covers the piping that's or whatever's insulated underneath it, or hidden line insulation, which will show it as a hidden line in the orthographic view. So those are 3 options that were added to this ribbon, which is a contextual ribbon within the ortho editor. And of course, the layers are set up within your ortho template as far as colors that are set up in the line types. You can also modify that within your project setup. So when you OK out of this, it'll place that ortho in there and generate it. And you can see the current settings will be displayed in that view. In this case, we have the hidden line for the insulation shown. And yes, to answer your question, James, the insulation transparency does translate to Navisworks. Okay. So we'll jump ahead here to a little bit farther ahead so that we can see within the layers for the ortho view itself, it has its own piping layer and insulation layer and a centerline layer. So you can see that it actually is generating a separate insulation layer for the views, just like it has a separate insulation layer for the 3D models themselves. Okay. So within project setup, going into the orthographic template, we can set up the title block and manage the layers that are used and their properties. So within there, you'll see the insulation layers are set there, and they're available based on the ortho template. And they are populated here within this dialog box by reading that ortho template. So this is him showing how from the ortho ribbon, you actually have the ability to select the insulation tool from that ribbon, and you can place it on the pipe. So if you have an existing pipe that's got insulation, and you don't want to go in and edit the view to show it all over the entire drawing, you can just place insulation as needed throughout the ortho. So I'm looking at the questions here. And so James asked a question. It sounds like the installation view styles per each view drawing sheet. Can you overwrite individual items in a given view? And no, you can't. That is set per view within that view editor. So you will be setting all of the appearance of all installation in that view that same way. If you have specific displays that you want, you might have to use this sort of installation annotation that we're showing on the screen right there, which Bernd is also showing at this point is editable with the grips, and you just need to redraw the view, and it will, when you update the view, it will show it properly hidden, even though you've edited the annotation with the grips. So. And as far as another question that we have here is about the bill of materials in the orthographics. And it does only include pipes and their components. It doesn't include equipment and structures. I don't think that you can actually add like an instrument or equipment lists or you know, structural material lists on the ortho. I've never been able to do that. And so I'm not too sure that that's possible. Daryl has a great question there. Buddy, I cannot remember. Is there a similar installation symbol for ISOs? I believe that there is.
I think so as well.
Yeah, I think that there is an installation symbol like that on the ribbon that you can pop on a 3D model, and it will show up on your ISO, and then you can configure that ISO S key for that. So thanks, buddy, for contributing there. Okay, so now we'll move past Bernd's video there without audio. So hopefully I did it some justice there. So we talked a little bit about the installation, and we talked about the 3 different display modes there, as well as that installation tool that you can annotate there. Just to recap, the installation is placed in a separate layer in the 3D model with the underscore installation, sort of like underscore supports. Now, I will note that it is not currently configurable, so you can't go into Project Setup and change that layer name in the 3D model, but it is automatically created for you. If you have unassigned insulated pipelines, then it puts it on the 0 layer underscore insulation. So that will be the layer that it will put the insulation on, and it will also be by default transparent. And then installation of XREF drawings can be shown in the master drawing. In other words, it does recognize that insulation transparency and is displayed properly, whether you're in Navisworks or whether you're in Plant 3D and XREFing in your model. So, okay, just do a quick scan. Looks like our questions are getting answered very quickly. That's great. Thank you so much, Nabil. Appreciate that. And thank you, Roland, as well, buddy. Just making sure I scan down all these. Alrighty, so some of the do's and don'ts while generating ortho drawings. You want to keep your source drawings in the project under your proper folder structures. It's best not to try to reference in drawings that are not in the project. Now, there are ways that you can do that, but they don't always work properly, especially if you're working in a BIM 360 environment. So we'll talk a little bit about that, I think, in a few. Don't move your source drawings and don't rename your source drawings. Those are definite ways to break your ortho view. If you don't know this, the ortho view is really set up of a bunch of blocks in model space that are 2D representations of the 3D model in that view. And those blocks are linked through the database, the Plant 3D database, to the 3D model components that they represent. So we can regenerate that geometry in the ortho when you update your 3D model through that connection that we have in the project database in Plant 3D. So it expects that the blocks that are in your ortho point to database records, which point to valid IDs in the 3D model. If you rename your models or try to take an older ortho and copy it into your project, you might end up with getting disconnects there because the IDs won't match in the database, and so it won't be able to update the ortho. At that point, it loses its connection. So, question here from Aaron. It looks like Buddy's going to address your question about insulation on equipment and tanks. So I'm not going to address that right now.
You can go ahead and answer it, but if you
No,
want.
Okay. As far as I know, there isn't. But Buddy, if you have an answer for that, I don't think that there is a way to show insulation on equipment the way that we've just shown it on piping.
I
There's
agree.
no
I
release
was just going to take it up another notch and kind of get into a little bit more deep discussion with him about it. That's all.
Okay, great. Well,
Thanks.
thanks. Appreciate that. And thanks, Aaron, for the great question. So yeah, so as far as the connections go, this is sort of the same concept with deleting stuff out of your specs. If you do that, you lose the IDs that are stored that connect the specs to the catalogs and that connect the specs to the models. So if you want to keep connection in Plant 3D, you're better off modifying rather than removing stuff. And in this case, don't remove models from your 3D project if those models are referenced in orthos, unless you're ready to create those ortho views. If the source drawings or external references are overwritten with newer versions, this is pointing to the IDs again of geometry. Typically, we don't have any problems with the non-Plant 3D or XRFs being overwritten because they don't have intelligence to them, but there could be issues where you lose some intelligence there and the ortho view won't update again. So for a structural drawing, for example, which is not Plant 3D, let's say it's an advanced steel model, if you use the same name, you should be okay. But if you rename your external reference or repath it, it could end up breaking the link. Okay, some of the more do's and don'ts while generating ortho drawings. Don't edit the completed orthographic drawing in model space. This can break your link. So I'm going to pop over and deviate a little bit from our presentation here and get into an actual software drawing. This is a little 3D model here that I have and an ortho view that I created of it. And if I go to model space and look at this thing, okay, I'll set tile mode. And we'll go into model space and you can see this. There's all the blocks that are in the ortho view, and they're located at Z elevations pretty much of where they would be in the 3D model, if I look at it from the side there. But each one of these, if I go to the properties of it, I always like to get into the hood, so hope you don't mind. Look at this valve right here. It's I think that's what it is. It might be an orifice, but it's basically a block that's shown here. And that block is located, linked to a valve through the database. So this properties that I'm seeing here are actually showing me the connection that it has to that other model, which is my piping 3D model. And it's data from that model as well as some of the tag information. So that's a temperature valve there. So that's part of a control valve. And in this case, you can see the PNP GUID, which is the unique ID for this object, which is linked in the database to the actual 3D model. So if I go in here and start moving stuff around or exploding blocks or whatever, I'm going to be creating a disconnect with my 3D model. So we'll go back to tile mode equals 0. And we're back here, and we can be back in paper space. So here's my ortho view again back. So it looks like the 3D model, but it's really made up of 2D blocks, and those 2D blocks are generated by our software using AutoCAD's hidden line removal algorithms. So I just want to switch back to my presentation here. So yeah, please don't edit those orthographic drawings. However, I've seen people do some tricks in there where they'll actually place 2D geometry in there that's not in the Plant 3D model and have it actually show up in the actual orthographic view. So there's some tricks people have done, but just so you know what's going on behind the scenes, so you can kind of get a feel for how to play with that magic. So we do recommend you use one layout tab per orthographic drawing. I've seen people try to use multiple layouts. It doesn't typically work. You can have multiple views in the single layout tab, but your paper space layout tab. But just go with the one. Your Plant 3D model should be in plant coordinate system and close to the 0, 0 origin, because if you get out to very large coordinates, and by large coordinates I mean usually 10 to the 6th power, so we're talking around 1 million or so units, whatever they are. Usually it's inches in America, might be centimeters in other countries. You'll end up with the problems with orthographic views not generating properly, lines being dropped or not hidden, and it has to do with the floating point issues that AutoCAD has with large coordinates. It's also something that you'll see where if your 3D models are at large coordinates, they may not connect properly. So we do recommend that you work with a plant coordinate system closer to zero, and if you have to work with civil models or other models that are out there at real world coordinates or state plane coordinates, then you XREF in the plant model and then translate it or transform it to the right coordinates. And there's an article here that will be posted in this PowerPoint, which is how to work with actual coordinates or real world coordinates in Plant 3D. So this covers some of the scenarios there so that you have that. Yeah, so Mayor Weiss had asked if you want to add some 2D objects to the view, for example, column grids or hatch lines. Yes, you can get away with that by throwing that into model space, but just be aware, there may be some, it may delete them, so have that geometry handy. When you regenerate the view, it may clear out that model space of those entities. So your column lines or hatch lines or whatever. But they should also be okay to put those in the 3D model. And when you're generating the ortho view, they'll come through fine. They won't get hidden out. But if you do need to add something into the ortho view, I've seen people do it. It's not a recommended practice, but it doesn't break anything. But it might be erased when you update the view. So continuing on this slide here, using proper workflows and file formats when incorporating models and drawings from other Autodesk or non-Autodesk software products is a do. That's basically a please do this. And this article is an example of a proper workflow. So, okay. So how to create a custom ortho template. Under the Home tab in the project panel, you can go to Project Setup, which you guys have seen that before, and it was actually shown in Burns' video. Under the ortho drawing settings, you have the select title block display setup, which is really what you're seeing on this image on the screen on the slide to the right. The ortho drawing output folder is defined. It defines the location of where ortho is going to be created, but the template you can see is actually shown here on the screen, and it's looking from my roaming profile here in this case. So we are able to set that in Project Setup, tells it where to go get that ortho, and you can set up layers, additional layers if you want them. The layers definitions will all be defined in that ortho, as well as if you have any blocks or whatever that you need to set up there, XREFs, they're all going to be for your title block. They'll all be stored in that ortho template, and that's what gets used to create a new DWG, ortho DWG. Now, once you've created the ortho drawing, going out and modifying the template won't update that drawing, of course, because templates are only used for creation of the new drawings. So you would have to then add extra geometry or whatever to your ortho drawing itself, or recreate that ortho drawing again anew, because the template is used once to initialize that ortho for the first time. Ortho generation options include a tool that allows headline piping to be shown by default. That's the checkbox that you see on that dialog box there on the right, and that is by default set that way. You can also control whether your center lines for elbows are shown as cornered or curved and that's an option I've seen out there with different standards. So, so you have the option of setting it to follow the center line of the elbow, or just showing the intersection of the two pipes that are connected to the elbow. So these are the settings in Project Setup. Okay. Now, things to configure for a custom ortho template. The layer setup option is there, and I'm going to go into this. You have ortho generation settings dialog there, as well as, like I said, the layers for equipment, center lines, even objects that may not be in the 3D model. You can create those layers in the template so that they're there for you if you have to do some drafting or insert some geometry to finish up your ortho. Your dimension styles, your multi-leader and text styles can be set and edited there. It's referring to them in the dialog box I'm going to show you, but it actually, those are defined in the template itself as far as the actual styles available. And then there's also a couple tabs for BOM setup there. So we'll go ahead and switch over to my Plant 3D setup here. And I'm going to go ahead and right click on that and go to Project Setup. And we will switch down to the ortho view. Okay. So here we have the ortho drawing settings, and the title block and display are set up here. If I go into Setup Title Block, it tells me that it's to assign layering, edit the title block, specify default styles. So when I go into this drawing here, I am in the actual Ortho Styles DWT, which was pointed to in the project setup. So that path that we saw, which I'll flick back quickly to that deck. This path right here is what drawing I'm opening when I click on the setup title block. So when I'm here, here's the tabs that were referenced. The ortho settings contains the layers, and you'll see that the insulation layers would be here. I'm not seeing it. There it is right there at the bottom. So I can define from the layers that exist in the template which layer I want the insulation to show up on, and that happens to be the one. Or you can also have the option here of using your 3D model layers. So instead of using this mapping here, it will use the layers from the 3D model, and they'll be identical in here. Now you also have the ability here to pop up your layer dialog from that ortho settings, and oops, I didn't want to do that, but let's see if I can get it to not dock and still display. So you can actually add layers if you need to here within the ortho generation settings dialog. It also lets you define in an ortho what's the small bore piping break. And this is different than the break that you see in isometric. So they could be set differently. I don't see people usually doing that, but if you need to here, you're setting it so that it can define the small bore piping from the regular piping as far as what layer it goes on. Isometrics have other rules for like vents and drains, and the way small bore piping is dimensioned is different in isometrics. So you have these breaks that you define in both isometrics and orthographics, and they are separate. Then of course your dimension styles are here. This is the available list of dimension styles, which there's only one in this drawing. And if I wanted to go in here, I could actually define a new dimension style using the dimension style manager. So it's all right here in the dialog. Same thing with the multi-leader styles. I can go to the multi-leader style set up there and the text styles as well. We have table setup here, which is going to define the different tables available in this this ortho, as far as, is it a simple BOM, is it grouped with category titles, is it grouped with independent columns? And once again, we don't have equipment here. We have and no structural steel, just the pipe and the pipe components are available. These are the different types of bills of materials formats that you can have there. Not quite as robust as the isometrics. And you can add additional columns if there's properties that you want to bring in to this. You also have the settings that are specific to the bill of materials, whether you want to sort it a certain way, how you're going to show cutback elbows, how fixed length pipes are managed, and also the descriptions for the bill of materials, what descriptions you're going to use, whether it's the size of the family descriptions. And of course, placing the bill of materials on your ortho is right here, and we can return to project setup. So I just wanted to show you that. I'm going to discard the changes so I don't have any unforeseen circumstances next time. And we'll wait for project setup to come back. And we'll get back to our presentation. So what I just showed you was this stuff right here. And of course, this slide deck will be available and this recording will be available for later reference if you need it. So when you have to create an orthographic drawing with XREFs from Inventor, what we do recommend first is that you, in Inventor, you shrink wrap that assembly, kind of get rid of any geometry that's in Inventor that's unnecessary. There's ways to clean up, say for example, remove any nuts and bolts, things that you don't necessarily need, because we're using the AutoCAD hidden line removal algorithms to generate the orthos. Just bringing a straight Revit model that was exported or an Inventor model that wasn't shrink wrapped can cause some performance issues, and you might be sitting there for a while waiting for your ortho to generate because of the unnecessary geometry. So from Inventor, for example, we recommend that you bring in an ADESC file, which is the BIM export, the AEC export file that's available in Inventor after you've shrink wrapped it. And then you can either associate that as a piece of equipment or just bring it in as an actual explode it to an AutoCAD block and use it that way. It depends on whether you're using it as a piece of equipment or not. And then when it creates the ortho drawings, then you'll have that equipment model that you can select for inclusion if you wanted to from the dialog. You could also be part of a plant model, and then it's automatically going to be selected. And that is when I'm talking about that. If I go to create a new orthographic drawing here, I'm going to call this right there. And when I create the new view in this orthographic drawing, it will have the ability to pull in all the drawings that are referenced in the piping model. So if you have to bring in something that's not one of these models, you can always XREF it into a model that's a piping model. That piping model might be blank, but it can have your geometry in it from other sources. So that's one thing that we recommend, because you only have the choice here of in your ortho views to actually use plant 3D piping models, because the intent of the ortho view is to connect those 2D blocks through the IDs in the database to the 3D models, which are shown here. So that's the key functionality. You can work alongside that, like I said, by XREFing in models to your plant models, but you want to be aware of the sort of the functionality that's there. So for example, with advanced steel, you can place your advanced steel drawings in your Plant 3 project directory as an external reference file. In other words, you can add them to the project, and making sure that you have the advanced steel object enablers or advanced steel installed on the computer, and that you have an origin location that's correct, that matches with the Plant 3D project. You can go ahead and bring that advanced steel model in as an XREF, and it will display properly. The display of the advanced steel objects in the ortho is going to be determined by whether you have the object enablers there. You can also generate steel and structural objects in Plant 3D. To some extent, it has some structural steel elements there, and you can export those out to advanced steel and then read that file in using the advanced, and that's actually should say advanced, not advanced, but there should be a C there for that second V, but it's advanced steel export. And that you just type that in Plant 3D, and it will export out your steel to a model that file that can be imported into advanced steel. I believe it's an XML file. Okay, and just so we have that functionality understood, I'm going to go back to Plant 3D here, and in my source files, I have under related files the ability to copy a file into the project, which would be like an advanced steel model. I can also use the XREF command within Plant 3D, and it will bring the model in here to the project and add it to the related files. So, okay. So some articles here with links, and this is a shout out to some of our partners who have written some really good articles, as well as the in the pipes blog that we do as support people here at Autodesk for Plant 3D. So here's some. It starts out with an AU class on Plant 3D orthographics back in 2015. There's some do's and don'ts in the pipes with the orthographics, and some knowledge articles there, as well as a couple of partner blogs there at the bottom. So just wanted to make sure that you all had that. Thanks, Roland. Thanks, Buddy, and Nabil for answering all these questions in the chat. Appreciate that. So question follow-ups. These are going to be questions from last month's session, which was a comparison of Revit, Plant, and sort of deciding, where to use the different products for the different applications. So I'm going to kind of cover some of these questions, but all of the questions that were asked were answered and are available on the Plant Community Meetup resource store. So I'll click on that after I'm done kind of reading through these. This is from our May 12th meeting that we had. And there was a question about, can you link both Revit and Plant models inside BIM 360? The mechanical model being done in Plant and the structural model being done in Revit. In the past, this person could not see them together. And with BIM 360 Coordinate, you have the ability to work with DWG files and Revit files, I believe IFC files as well. And you can use those with BIM 360 Coordinate to actually do clash detection. And Buddy had a really good webinar that he did last week rather, that was, I think it's available out there for you to look at. And it talks about how, actually it wasn't Buddy, I'm sorry, it was Steve Bissett that did this. And it was about how you use Navisworks with BIM 360 Coordinate. So you can actually do clash detection both in the cloud, which it's done automatically for you, and see the issues and actually review the issues in Navisworks. So there's some workflows that are being enhanced using BIM 360 platform to be able to do this collaboration. Doing it with the desktop apps and doing file conversions still requires you exporting to DWG from Revit to bring it into Plant 3D, and we do recommend cleaning up your Revit models before you do that. And of course, if you're going from Plant 3D into Revit, you need to do export to AutoCAD to get pure AutoCAD solids out so that Revit can work with those. Another question that came through last month was their problem in Revit was it doesn't slice the Plant 3D models while working in plan views. And so this mentions again why you need to do that export to AutoCAD command and then use an in-place generic model to link it in. So, and then we have some questions in the chat about these topics. These are all going to be on this virtual community meetup resource store. So the last question that I'll verbally cover here is, how do you coordinate with IFC files through Revit? And that's actually a spelling error on my part, sorry. You can link an IFC into Revit now. It's a new feature, but you can also push these into BIM 360 design as well as coordinate. So I'm going to click on this link here and see if I can bring that up. This is the Customer Success Learning Hub I was talking about, and this is the resource store where you can see different months, different recordings that we had there, and you can look at the presentations here. There's some that are available in this YouTube playlist, which you can go to, and here's the questions from in May where we did this session with Revit, and you can look at all the questions and the answers there. So the YouTube playlist is available, as well as presentations from our 3 different geos. You are in the Americas session, in case you didn't realize that, but we do 2 other ones for the other parts of the world out there. So, okay. So we got some questions here unanswered in the panel. Is there any flow that you could recommend for IFCs other than go to AutoCAD architecture? I'm going to have to say for IFC, you're going to have to go to Revit or to BIM 360. Right now, getting IFCs into Plant 3D directly into AutoCAD is not going to be a route for you. Louis Carr, that's the best I can do on that one right now without doing any research. Let's see if we have any other ones here. Looks like other questions have been answered, and hopefully those answers are all public. Nabil and Buddy, are you sharing those with everybody?
On some occasions, I am.
Okay, good. So that way, if you want to, you can look at the questions, you can see the answers there. Plant 3D metadata available inside Revit? No, not at this time. Mr. Tyner, thanks for joining. Appreciate having your presence here. It's something that we do see as a completely workable workflow in BIM 360. In other words, you can bring in your IFC data with your IFC models with its data, Revit with all of its data, Plant 3D all with its data into the BIM 360 coordinate space and BIM 360 design. And with Plant 3D 2021 being able to work in that BIM 360 space, and with BIM 360 coordinate being able to access the project files folders in BIM 360, we now have the ability to do quite a bit in that. So, and there are plans, but this gets into our future speaking of, don't take this to the bank, but we are working on making Plant and Revit, not just Plant, but Revit and our other products work better together when it comes to file sharing, not just information collaboration in the cloud. So this is something that's really important to us as a company. I know that you've probably heard it in past years. We've had a lot of re-emphasizing of this from our highest levels of management at Autodesk, that this is really where we're focused. So I think that we'll be seeing some good things coming out over the next year or two. So I'm looking forward to it. Okay. Let's see if we got any other questions. I don't really see any other ones that are unanswered there. Let's see if I can move my windows here. Oh, good. All right. So I think that's it. I think that we usually schedule about 45 minutes here. So I want to thank everybody for coming. And this recording will be available as well as the deck on the Customer Success Hub. So please take a look at that and have a great day. Thank you very much.